Hello, everyone. So, today we are going to cover an important question, a very famous question asked in many good companies related to binary search. That is a more, I could say, more optimized method than what we will be going to do today. But this is also a level of optimization only, a good level of optimization which you can do. A good question. Actually, Leetcode had a question median of two sorted arrays. So the question says that we are given two sorted arrays. So now we will apply whatever we have learned in 1D array. Until now, we'll be doing on 2D arrays mostly. But now let's say you are given two sorted arrays. So consider this as your first sorted array and consider this as your second sorted array. Couldn't be of the same size, it could be of size m and n respectively, and we have to return the median of the two sorted arrays. So if you forget, let me make you remind that median is actually the middle element after making a single array. If I make a single array of this, it would be what? Sorted. After sorting the middle element, 1 2 3 4 5 5 6 7 8 and 9. So then there are total how many elements? 10 elements. So then median could be if there are even number of elements. If there are even number of elements, then median could be fifth element plus sixth element. Both are center divided by 2. Okay. So here its fifth element is 1, 2, 3, 4, 5, and sixth element is also 5. So 5 plus 5, 10 divided by 2, 5. So median is 5 for this example, general case. Okay, so if you do it brute force wise, you need to sort both these arrays. Okay, you need to traverse n, m, you need to sort it. So the overall size has become n plus m. And then you need to find the median of it. And then you have to find the median from this. Again, to find the median, we will do middle element. So basically, it's order of n plus m in brute force. Okay, now we'll try to reduce this complexity. Okay, let's say median is what? Actually, we are learning kth smallest element, right? So median is actually what? Median is actually middle element. Okay, or middle minus 1 plus middle divided by 2 or something like that, like those kind of things. Okay, but median is what? Middle element. So actually k is what? K is your middle element here. So that k you need to find here simply. Now, for this type of questions, there could be so many edge cases which you need to think and then work on it. Okay, so that's another thing which I wanted to share in today's video, that there are so many edge cases. What could be the edge cases? N is the size of nums1 and m is the size of nums2. Now, there could be case that if n is 0, they have said that n could be from 0 to something, 1e4 or 1e5 or something 1e6 as of now. No, 1000 only. Fine, 1000 only. And m could also be from 0 to 1000. So if both are 0, of course your median will be what? 0. So I mean that case is solved. If only your n is 0, that means you have only one array, nums2. Okay. Now there could be two possibilities. It could be of even size and it could be of odd size. What if it could be of even size? So if your this is of even size, I mean your nums2 size is even in this case. So it could be this two indices. Indices are 0 based. Length is actually 1 based. Okay. If we consider length is 4. Length is not 3, 0, 1, 2, 3. No. Length is 4. But index is 0 based. So actually 0 to 3 indexes are only present. Fourth index wouldn't be present. So here your logic will be what? First index plus second index. Okay. So if the size is 4, 4 divided by 2 is 2. But a minus 1 of that index should also we have to consider. We can take another example. Consider it be the six indices. So 3, 4, 5, 6, 7, and 8 also. Okay. Then it could be what? This two indexes 2 plus 3. 2 plus 3. So basically which two indices you are getting? Nums2 of m by 2 plus nums2 of m by 2 minus 1th index. This whole divided by 2. And the median could be the float value. Okay, median could be the float value. So this you have to do floating of it. So how will you do it? Into 1.0 divided by 2.0, so that it gives the answer in the float. This you will return. What if it's single? I mean, not single, it's odd. Okay, so consider this as the odd. If I remove this, then it could be only first index. Okay, only first index. So m by 2 minus 1 index every time. Let's say if I remove this, then it could be second index. So m by 2, 5 by 2 is 2, 3 by 2 is 1. So not minus 1, only m by 2. Will return nums 2 of m by 2 as it is. If you want the float, you'll just do minus 1.0. The same case for m is equal to 0. Okay, same case for m is equal to 0, and we need to replace m with n and n with m. Okay, done. Now the main case arises when both of them are not equal to 0, which is our original case. Okay, when both of these are not 0. So if n plus m divided by 2, so modulo 2 is 0. So in this case, this 5 plus 5, both are odd. So actually n plus m modulo 2 is 0. So 10 divided by 2 is 0. So that means my answer will be fifth element plus sixth element divided by 2. So I need to find kth smallest element. So fifth smallest element and sixth smallest element after merging, but I will not merge it. What I'll do? I'll find all the elements. I'll find all the elements that are less than this particular element. So I'll consider that mid is my kth smallest element. Mid is my fifth element. I'll consider mid as my fifth element. Okay. And I'll count the number of elements less than mid. That should be greater than equal to 5 because I have considered mid as my fifth element. Okay. So let's say I consider mid as, let's say, 6. So if I consider mid as 6, the total number of elements less than 6 are how many? 1, 2, 3, 4, 5, 6. Total number of elements is 6, which is greater than k, which is greater than 5, greater than equal to 5. So 6 could be my answer. 6 could be my answer. So my answer lies on the left side. When this happens true, then I'll do r is equal to mid. That's what we are doing from last 2-3 videos. Okay, that's what our template. That if it is satisfying the number of elements less than mid greater than equal to k. Here k is nothing but your k you have to define. You have to define which k's you want. So if your n plus m modulo 2 is 0, then you could have two k's. You have to apply the binary search twice. Okay. One for this element 1, which is what? Fifth element plus sixth element. So n plus m divided by 2 and n plus m divided by 2 plus 1. Okay. N plus m divided by 2 and n plus m divided by 2 plus 1. Otherwise, in else case, it would be, let's say if there are only 9 elements, okay, then it could be only fifth element. 0, 1, 2, 3, 4. So actually fourth index. But k shouldn't be. Here we have to define k's. Okay. K shouldn't be 0 based index. So this wouldn't match. This is m by 2 and m by 2 minus 1. But here why it is n plus m by 2 and n plus m by 2 plus 1? Because this is 1 based. Because here you are defining k's. Okay. You are defining this k's, different possibilities of k's, which is not 0 based, which is 1 based, because k is an integer. Kth smallest you are defining, kind of length is 1 based. How 1 based? I showed you, like 4. So but the indices could be from 0 to 3. So kth smallest element, third smallest element is actually which index? Third smallest element is actually second index. Okay, so that's how it is defined. So that's why it is n plus m by 2 and n plus m by 2 plus 1. Otherwise it would be what? Only n plus m by 2. Only fifth element. From 9 elements, only fifth element is the middle element. Okay, so fifth element is actually index what? Fourth. But we don't need index. We want k because we know how to solve the kth smallest element with this kind of questions. Okay, and then how we will solve it? Okay, so your bull is possible. could be how? You have one mid, you have two arrays, okay, nums1 and nums2. You have two arrays. Then you have to find number of elements less than mid greater than equal to k. Okay, that number should be greater than equal to k. So you will count the number of elements less than mid, less than equal to mid. Okay, how we will count? In the very first question, the first question we have solved in the array, because this both arrays are sorted, number of elements less than equal to mid could be found by upper bound, because upper bound will give us the first index which is greater. So that index means that much elements are less than or equal to mid. I won't go in deep. I can share the link of that video where we have solved this for 2D array. It's kind of a similar only. Okay. So without wasting time, let's just solve the question. Cool. So we have to solve this question and we have to return the median of two sorted arrays double. Okay, float or double in this case, not float. Float would be in C, here it would be double. Okay, so we could have first the size of nums1 and m is nums2. Okay, all three possibilities, which very first is n0 and m0. Then in that possible case, it would be what? It would be return 0 only, nothing else. Otherwise, uh, if n is only 0, then there could be two conditions. If m modulo 2 is 0, then we have to return nums2 of m by 2 plus nums2 of m by 2 minus 1 into 1.0 divided by 2.0. And this could also be in one bracket. This should be happen first and then this division. Otherwise, we'll return what? Nums2 of m by 2 simply. The same case could be applied if m is 0, replacing m with n and n with m. And instead of nums2, it will be nums1. Okay. Now there could be two conditions. Okay. First, let me make the binary search so that you could understand. So a binary search would return what? Median of two sorted arrays, a number, I mean fifth smallest and sixth smallest. So it couldn't be double. Fifth smallest element it will return, and it could be from nums1 or nums2, either. Both of them are integers. So we have int kth smallest I could write simply, and then we could have one uh, k element and then this two vectors nums1 and nums2. So our L could be minimum of nums1 0 or nums2 0, whichever is minimum, a minimum of both, and R could be a maximum of both, a maximum of nums1 of n minus 1, n would be this size, and m would be this size. Okay, so n minus 1 and nums2 of m minus 1. Cool. And then we have while r minus l greater than 1, mid is l plus r minus l divided by 2. So we consider mid as kth smallest element, and from where this k will come? This k will come depending on n plus m is even or n plus m is odd. If n plus m is even, we could have two k's, n plus m by 2, n plus m by 2 plus 1. Otherwise, we could have only one k, n plus m by 2, and that we have understood. So if is possible of mid k nums1 and nums2, then r is equal to mid, else L is equal to mid plus 1. Again, we will check for is possible for L first. So is possible is for L first. If it is possible, we'll return L. Otherwise, we'll return R. Okay. Now, this condition could be if n plus m modulo 2 is equal to 0. That means it's odd. So there could be two elements. Okay, I could check k1 and k2. K1 could be n plus m divided by 2. So we will do the kth smallest for k could be here what? N plus m divided by 2. I need to find n plus m divided by 2 value for nums1, nums2. And k2 could be what? Kth smallest n plus m divided by 2 plus 1 and nums1 and nums2. Okay, and this could be k1 plus k2 into 1.0 divided by 2.0 as we have done above. Okay, this could be this. Else we will return what? Else we have only 1k. Else we have only 1k. Whatever is the value coming for n plus m divided by 2, that is the only case we have now. That that itself we will return. Cool? Okay. Let's see. Now we are left with is possible. These are the kind of questions where you learn how to make the functions, how to define the variables, how you can traverse line by line to each function. Okay. Now the task is to find the kth smallest. Is this kth smallest or not? So we could have mid, we could have k, we could have two vectors sorted. Okay. Nums1 and nums2. Fine. We have to count. So we'll have count 1 as 0 and count 2 as 0. Why count 1, count 2? I need to find the number of elements less than equal to mid in both of the arrays, nums1 and nums2. Right. So first, count 1 would be what? Upper bound on nums1 dot begin, nums1 dot end, and for mid, less than equal to mid, minus nums1 dot begin. And count 2 will be upper bound. This will give us the index and how it will be same as number of elements less than equal to. I've explained already in the first video of this series, number of elements less than kth smallest element series. Okay. So you can go and watch out over there. Now this total count 1 plus count 2, total number of elements less than equal to mid should be greater than equal to k. This should be greater than or equal to k. If it is true, it should be greater than equal to k. Then we are good to go. Let's run. I hope without error it will pass. But I hope you have got the things on how to do, how to match, how to do this fixings. Okay. This would be 1, 3. So 2 plus 1, 3. So n plus m wouldn't be here. So 3 means I need to do 3 by 2. First smallest element? No. I need to find the second smallest element for 3. Second smallest element is nothing but n plus m by 2 plus 1. Right. Let's say. Okay. This way you can try and run the test cases and then you will be able to solve for this type of questions where there are so many edge cases. Correct? So basically if we want to calculate the time complexity also we can do. Nothing over here. Okay, directly kth smallest element. If I go to kth smallest, oh sorry. If I go to kth smallest element function, this is the binary search. This binary search could run, let's say for merged array also it will run in this much time complexity only because I have defined L and R to be zeros and n minus 1. So consider that it could be 0 value could be 0 and this value could be minus 10 to power 6 to 10 to power 6. So total would be 10 to power 12. So log of 10 to power 12 and is possible will run upper bound in nums1 array and nums2 array. So maximum of this both n or m. Okay. So it wouldn't take more than n plus m, log of n plus m. But still there are a better time complexity in which we can solve this. So we could see it later sometimes. Okay, stay tuned for the next set of series. We are done with the binary search now. I could uh, put another question of similar kind, wherein we are given two arrays sorted like this, and we have to do something with the multiplication product of the elements. Similar kind of questions, you just need to think a little bit on it. I can put down here in the comment section. And yeah, the next series could be monotonic stack, so stay tuned for that. Until then, stay safe. Do like, share, and subscribe if you have learned a lot out of this. Bye bye.